Okay, so as I said, in the last session on Wednesday, we were solving this case study on social network ads.csv, wherein we have implemented our KNN model, KNN classifier, right? And at the end, we had imported certain, let's say, functions like accuracy score, confusion matrix, classification report. Now, definitely, we had imported this functions to evaluate our model, but we are not aware about what exactly accuracy score means, what is the formula, how do we calculate it, what exactly confusion matrix is, and what is the use of classification report. Okay, so today at first we'll study about these terms and then we'll talk more about the report that we are getting over here, right? If you see in this classification report as well, there is something called precision, there is something called recall, there is something called F1 score, right? So what exactly these terms, this terminologies means? Okay, what exactly this is to do with your machine learning model or evaluation of your model? Okay, definitely we can understand when it comes to accuracy, that basically mean how good your model is performing. But what about this confusion matrix? What kind of square matrix is this? What this report says? Okay, so we need to learn how to interpret this report, how to understand how good my model is with respect to this confusion matrix, right? So today we are going to learn what is confusion matrix at first. Now, why confusion matrix is important? Because when it comes to accuracy score and classification report, I would say confusion matrix is the mother of accuracy score and classification report. Okay, so by using this confusion matrix, you are able to draw accuracy score and this classification report. Okay, let's see how. So when it comes to, let's say, confusion matrix, guys, confusion matrix is a squared matrix or is a table that is used to define the performance of classification algorithm. Okay, we cannot use or implement this confusion matrix over regression problem, guys. हम सब ने देखा है कि रिग्रेशन में there is something called as mean squared error, mean absolute error, r squared, and root mean squared error. Those were the evaluation metrics in order to understand that how good my model is doing. But when it comes to your classification model, these are the things that we use in order to get the performance of your model, right? So let us see what exactly these means actually. Okay. So before that, let me give you a scenario first. Okay. So let's assume that we have got certain samples. Okay, we have got certain samples. Let's say, let's give it a number 200. Okay? There is 200 samples of COVID test reports. There is 200 samples of COVID test reports. That means we have somewhere around 200 patients with us. Okay, we had, let's say, asked them to get the report whether they had COVID or not. Okay, and let's see what happened or what interpretation we got when we get the report done for COVID. All right, so before starting, let's say there are certain terms, guys, that we need to understand. There's something that we call as actual no. Okay, definitely when it comes to your COVID test report, the answer will come in yes or no, whether a patient has COVID or whether a person don't have COVID. Okay, so actual no, you can also refer it as actual negative. The patient is COVID negative. In actual, in reality, the patient is negative, right? We can also represent this negative as zero, right? Then the second scenario is actual yes or positive. The COVID, I mean, in reality, the patient is COVID positive. It can be also denoted as one, right? Similarly, now guys, understand that this two scenario is the real or the reality. Okay, this situations are the reality of the patient, whether the patient actually have covid or don't. Okay, या तो पेशेंट को कोविड है या तो पेशेंट को कोविड नहीं है इन रियलिटी. Okay, but now when it comes to your model, let's see what your model says. So this is something called as predicted no or predicted negative. Now here doesn't matter what is the reality, whether the patient has covid or not. Model will say that no, the patient do not have covid. Okay, so here model is predicting that the patient is covid negative. Okay, the patient do not have covid. Similarly, there is a situation also, this scenario of negative can be represented as zero, right? The scenario can be represented as zero as well. Okay. Similarly, there will be one more situation where we'll say predicted yes or positive. Okay. Predicted yes or positive. Also, this will be referred as one. So what we are doing is we are examining whether the patients have covid in reality and what is the prediction of your machine learning algorithm. Okay, whether your machine learning algorithm predict the same result which is there in reality or predict something different. All right, so confusion matrix is kind of an error matrix, error evaluation matrix that we get. All right, so let me create the square matrix or square table over here. So this is a square matrix. Then this is the first column for actual no, okay, or actual negative. The second column belongs to actual yes or actual positive. The first row belongs to model which is predicting that the patient has COVID. Sorry, patient don't have COVID. And the second row belongs to the model which says yes, the patients have COVID. All right. Now let us understand what the numbers. If you see, there are certain numbers here. That is 59, 9, 8, 24. So what these numbers are. All right. So as I said, there are 200 samples with us. Right. There are 200 samples with us. हमारे पास 200 sample है guys. हमारे पास 200 patients हैं basically. Okay. Now let's talk about first the actual no. That means in reality, these people do not have COVID. Again, I repeat, let us talk about the first column, that is the actual no or actual negative. That means in reality, these people do not have COVID. Okay, they are COVID negative. The reports are negative in reality. Okay, now here we have something called as predicted negative or predicted no. Okay, which is good thing. Now why it is good? Because actually the patients are negative. In reality, the patients are negative, and your model is also says that they are negative. So this situation here is called as true negative. Okay, this situation here is called as true negative. That means your model has successfully, let's say, identified all those people who are actually negative. Okay, so let's say there are altogether 25 patients who are actually covid negative in reality, and model also says that they are covid negative, right? That is a good thing. Okay, so here as I said, there is something called as true negative. Okay, now what true negative means? True negative is when the model predicts negative and in reality they are negative. ओके, रियलिटी में भी वो पेशेंट्स को कोविड नहीं है और मॉडल भी वही बोल रहा है कि हाँ इन पेशेंट्स को कोविड नहीं है. मतलब मॉडल अच्छा काम कर रहा है, ठीक से आइडेंटिफाई कर रहा है वेदर पेशेंट हैज कोविड और नॉट. ओके, देन We have a second scenario. Okay, scenario number two. Again, actual no, that is in reality इनको कोविड नहीं है, but if you see this row, the second row over here, predicted yes, but model is saying that they are covid positive. एक्चुअली इनको कोविड नहीं है, बट मॉडल क्या बोल रहा है कि कोविड है इसको. मॉडल क्या प्रोडिक्शन दे रहा है कि कोविड है इसको, जबकि उसको कोविड नहीं है. राइट. So this scenario over here is known as false positive. That your model is falsely predicting that they are positive. I repeat that your model is falsely predicting that they are positive. In reality, they are not at all positive but negative. They don't have COVID, but your model says they do have COVID. There are some around 10 patients who don't have COVID, but model says that they have COVID. All right. So this is the second scenario of false positive. FP, false positive. That is, model predicts or model predicted that the patients are positive, but in reality they are negative. Okay? They don't have COVID, but in reality they don't have COVID. That is false positive. All right. Now, this is an error, guys. The false positive situation over here is kind of an error. Okay, we'll talk about it in later. So, this false positive, where in reality the patients do not have COVID, but your model predicts them as COVID positive. This is what we call as false positive, because your model is falsely predicting that these people are COVID positive. Okay, so this is the first column of actual negative. Let's talk about this actual yes. Right. So when it comes to actual yes, it simply means that these people will definitely have COVID. इनको रियलिटी में कोविड है. ओके. अब मॉडल क्या बोल रहा है? मॉडल सेज प्रिडिक्टेड नो. ओके, मॉडल प्रिडिक्टेड नो और नेगेटिव. दैट मींस मॉडल तो गलत बता रहा. राइट. मॉडल तो हमारा गलत बता रहा है कि इनको कोविड नहीं है, जबकि उनको कोविड है. ये भी एक एरर हुआ. दिस सिनेरियो हियर इज नोन एज फॉल्स नेगेटिव. Right. This scenario here is known as false negative, because the people belongs to this category do have COVID, but model says that they don't have COVID. Now this is more dangerous. This false negative situation is more dangerous than false positive, right? Because in reality these people have COVID, but model says they don't have COVID, right? So let me give the number. Let's say 15 patients are there who have COVID, but model predicts that they are not COVID positive. Okay, they don't have COVID. This is what your model says, right? This is called as false negative. Model is falsely predicting that people are negative. Okay, predicted negative, but in reality they are positive. Okay, but in reality they are positive, right? This is also a kind of error, where your model is fails to identify whether the patient has COVID or not. All right. Now we have the last situation, where the person or the people are actually positive, and your model also says that yes, they are positive, right? The scenario here where the people are actually positive and model also says yes, that they are positive, right? So this scenario is called as true positive. This scenario is called as true positive, where people are actually COVID positive, and model also says that yes, they are positive. So here, the model has correctly identified the people who have COVID positive, right? So there are, let's say, 150 people who are COVID positive, right? Now these number will definitely tell you about what are the amount of what is the frequency of the people where your model correctly evaluated whether the person is positive, that is 150. What is the frequency of the people where your model is correctly evaluated that person is negative, that is 25. And what is the amount of error that do we have overall? If you calculate 15 plus 10 is 25, so there are 25 people for which your model is misclassified whether they are COVID positive or not, right? So we'll understand this as well. First, let me write this again. Last one is called as true positive, TP, right? Now what this means, the model predicted positive, the model predicted positive, and in reality as well, they are positive, right? In reality as well, they are positive. So these are the terms, that is true negative, where your model has correctly identified to the people who are actually COVID negative, who don't have COVID. In reality, they don't have COVID, and model also predict that yes, they don't have COVID. Then there is something called as false positive, where your model has falsely identified few people that they are COVID positive, but in reality they are not COVID positive. Then we have false negative. Now this is the situation where your model says that the patients are COVID negative, but in reality they are positive, right? In reality the patients are positive, but model says that they are negative. And the last situation, true positive, where in reality and prediction or your model says the same, that they are COVID positive. So this is something that we call as confusion matrix, where we can check whether whether how good or bad your model is. Both the matrix can be, both the values can be evaluated in a single matrix, that is confusion matrix. आप एरर के बारे में भी पता लगा सकते हो, आप एक्यूरेसी के बारे में भी इसी से पता लगा सकते हो. So everything that we have done in the coding, let's say your accuracy score, your classification reports, goes from this confusion matrix itself. Okay, goes from this confusion matrix itself. Is that clear till here, everyone?